To understand ourselves, we need to understand the universe around us. My name is Anvar Shukarov. I'm a professor. My area of research is theoretical astrophysics. I was born in Tajikistan, in Central Asia. It was part of the Soviet Union at that time. So immigrating twice, first from Central Asia to European Russia, and then to here. In the universe, we have the dominant force is gravity. The next important, I think, is magnetic field. And then coming down to smaller scales, then nuclear forces become important. Weak interactions of quarks and so on. But these are all microscopic scales. At the scales of astronomical objects, I think that gravity and magnetic field are the dominant players on that scene. Magnetic fields, they're very important. And enigmatic also. It's a force. But unlike gravity, which acts on any mass, magnetic fields and electric fields only act on charged particles. This is why it is important that, for example, magnetic field doesn't affect the motions of air around us, because air is neutral, it doesn't conduct electricity. But in the universe, virtually all gaseous matter is in the form of plasma, it's ionized. Electrons are detached from protons and other nuclei. Then magnetic fields affect them. So it is a force produced by moving charges and acting on moving charges. In the same way as a gravitational force is produced by masses and it acts on masses. So the difference is the magnetic field requires electric charge to become important. Well, the compass works only because the Earth has its own magnetic field. So this is the first, call it application, of natural magnetic fields that we human beings discovered using the compass. So the Earth core, it consists of melted iron with other admixtures, and these motions of that conduct electric fluid generates this magnetic field. It's a fascinating phenomenon, it's very non-trivial. How those motions there, which are largely disordered, how they produce this well-ordered magnetic field of the Earth. If it wasn't ordered, compass would be useless. It is useful just because the magnetic field of the Earth has a beautiful, coherent, large-scale structure. But then, with time, we start observing other effects which are very deeply related to magnetic fields. For example, Aurora. This beautiful phenomenon is there just because if we move up in the atmosphere beyond about 20 kilometers, air becomes ionized. It starts conducting electricity. And where there is electricity, there is magnetic field. And this is where the auroras emerge, because then the electrons which are there, they are channeled along magnetic lines to produce all these beautiful and colorful patterns. It was discovered in 1908 that the sun has magnetic field. The sunspots are in fact the locations where magnetic field is very strong, so they look dark. Then, and this drives the solar activity cycle, they change actively, and then this activity cycle affects the interplanetary space, and it's called now space weather. The interaction of these interplanetary plasmas with the Earth are strongly affected by that. And the Earth magnetic field shields us from these streams of charged particles which come from the sun. So without magnetic field, life on Earth would probably will be impossible. If you move further out, you discover that the galaxy, the Milky Way, has its own magnetic field, which affects the interstellar plasmas in a very deep and highly complicated way. So star formation depends on magnetic field. Almost every aspect of the dynamics of interstellar gas is affected by magnetic fields. Then now we are discovering that galaxy formation even is affected by magnetic fields. Over the last 30 or 40 years, we have understood more about natural magnetic fields in the universe. There is rapid progress. It's a very rapidly developing area. What we want to have is a coherent and consistent picture of the world. Everything is connected in this world. What are these connections? How they combine into this complete and coherent universe of which we are a part.